All right, so we're going to look at the factoring and math knowledge question. After y'all have paused the video, I'll show you the correct answers. So for the factoring, you're going to start off by removing the 6 by multiplying it by that 1, and so you'll have x squared plus 5x plus 6, and then you'll say 6x plus 2, and then 6x plus 3, because you're looking for numbers that multiply to give you 6 and add to give you 5. So this first set will divide by 2, and you'll have 3x plus 1. The second set will divide by 3, and you'll have 2x plus 1. And so this would be your answer for your factoring. For the math knowledge question, we have an angle that's on the coordinate plane, the vertex is at the origin, and the initial side is on the positive x-axis. So we've got some angle here, and I'm just drawing it in the first quadrant. But there's our angle. We don't know what it is. It may not be in the first quadrant. We're not so worried about that right now. It tells us that in standard position, it is 1573, and it wants to know which of these other angles are the same as that one. And so it's going to be all of them are the same except for one of them. Now, if this x was a 30 degrees, I could take it and go around the circle a whole time, which would be 360 degrees. And then if I went another 30 degrees, that would actually be 390. 360 plus the 30 would be 390. Or I could go 2 times around the circle. 360 plus another 360 would be 270. And then I could go my 30 degrees. And so that would be 750, because we would have 360 plus 360 is going to be 720, plus 30 gives you the 750. These are all the same, and basically what you're doing is adding 360. Well, on this one, this is the bigger number, and we've got all of these numbers down here that are smaller. So what we're actually going to do is take 1573, and we're going to subtract 360. So we're going to subtract 360 from it, and we're going to get 1213. If you subtract 360 again, we would get 853. And so we're going to subtract 360 again, and you would get 493. So that means that D is the same, so it's not going to be our answer. If we subtract 360 again, we're going to get 133. That means that C is not our answer because that one works. If we take 133 and subtract 360, we're going to get negative 227. So that means B is not an answer. And then if we subtract 360 again, we get negative 587. And so A is not an answer. The only one of these that is not going to work is E, 573. And so that would be the correct answer for the math knowledge question. So we are looking at lesson 71. We're dealing with translations. So if you would like, you can do all of your notes for these on a sheet of graph paper. If you are in the room, look over at the filing cabinets, and it's going to be the third one from the left. It's the one all the way on the right. And I don't remember which of the drawers I put it in, either of the middle two. There should be some graph paper in there, so everybody can get a piece of graph paper. But if you would like, you can do your notes today on that piece of graph paper, or you can just get graphs from the front of the classroom and do that. So we're looking at translations. So hopefully after this lesson, you'll understand how to do translations. So a translation is an isometry. That means that the pre-image and the translated image are the same shape and size. So an isometry means the pre-image and the image are the same shape and size. They are congruent figures. For a translation, all we're going to do is take it and move it left, right, up, down, side to side, somewhere like that. We're just going to slide it. These are one of the types of transformations that we looked at a couple days ago. So we've got a triangle that has vertices P, Q, and R as given. We want to find the coordinates of the vertices of the image of the triangle after it's translated 5 units up. And it wants us to show both the pre-image and the image on the same coordinate plane. So you may need to pause the video for a second so that you can draw your X and Y axis. So we're going to start off by drawing our pre-image. That is the one that's given by these 3 vertices that they give us. So we have -4, -1 for P, and then we have -2, -4 for Q, and then we have R, 2, -1. And so we need to connect our vertices. And so there's your pre-image. Now the image, it is translated 5 units up. So basically, we take each vertex and move it 5 units up. So we're going to go 1, 2, 3, 4, 5. And that's going to become P prime. You have to put that little prime there. We move Q up, 1, 2, 3, 4, 5. And so that's going to be Q prime. And then R goes up 5 to right here. And so that's going to become R prime. And so now these are the image here and the pre-image here. So that would be part A. Now for part B, it says to show that the area is equal. To find area of a triangle, you're just going to do 1/2 base times height. The base on this one is 1, 2, 3, 4, 5, 6, and then the height is 1, 2, 3. So the area of the first triangle, 1/2 base times height, 1/2 6 times 3, which is 9. And then on the other triangle, 1, 2, 3, 4, 5, 6 for the base and 3 for the height. So we have 1/2 base times height, 1/2 6 times 3, which is also 9. And so that shows you that the area of the 2 triangles are equal. Looking at mapping notation. Mapping notation is used to indicate the way in which a point or several points should be transformed. So it's how you show how your points are going to be transformed. This is an example of mapping notation. We're taking point T here, and we're going, when we have our X's and our Y's, we're going to take our X values and add 1, and we're going to take our Y values and subtract 2. Okay, so this would be your mapping notation. We took point T, which was at XY, whatever point it is, we add 1 to the X value and we subtract 2 from the Y value. That's what a mapping notation looks like. So we have the vertices of our quadrilateral given as follows. We want to find the image after the translation given here, translation of our point of XY. We are going to add 6 to the X, and we're going to subtract 3 from the Y. And then we want to show the pre-image and the image on the same coordinate. So the first thing that we're going to do is to draw our pre-image. So we're going to have -5, 2 for D. For E, we're going to have -3. F is at the origin. And then this is G. Now I have had people that have connected these in the wrong order. It says D, E, F, G. So you need to start at D and go to E and then to F and then to G and then you go back to D. And so that's the figure that you should have. obviously with lines that are a little bit straighter than that. Okay, so that's the pre-image. Now the image. We are going to take each of our x's and take them to the right 6, and then our y's are going to go down by 3. So F is going to go to 1, 2, 3, 4, 5, 6, and then down 3. So F prime is going to go right there. G prime, 1, 2, 3, 4, 5, 6, and then down 3. D prime is going to go right here, and then E prime. It's going to go right here. And so now we're going to connect again, D to E to F, and then we go to G, and then we go up to D. And so that would be your answer for that one. For the next one, we want to find the image of the triangle LMN under the translation vector. And so I'm going to go ahead and draw in triangle LMM because you don't have it shown on the board. L is going to be at 3, -2. N is going to be at 2, -6. And then M is going to be at -3, -5. So that's the triangle that you should have. Okay. And then we're going to translate it under this vector. And so it takes everything and moves it to the left by 1 and then up by 2. So each point gets moved to the left 1 and up 2. And so this is going to be M prime. This point would be L prime. And then this point is going to be N prime. Now, the way that you have to do this for a translation vector, you actually have to connect each of your points with your other point there. So you would say from M to M prime, and you're going to draw a line there. So from M to M prime. And then you're going to put a little arrow because that's where you're going. You're going from N to N prime, and then from L to L prime. And then after you draw your vector arrows to show that's where it got moved, you connect your 3 vertices. And so if you did a better job than I did on connecting your triangles together, you actually have what kind of looks like a 3D figure. So that's how that one works. Looking at this next example, we have a flashing symbol in an animated movie. It's translated from the point -3, 12 to 8, -1. And it wants to know what vector can be used to represent that translation. So -3 plus what x value gives us 8? Well, that would be when x is equal to -11. And then 12 plus what y value equals -1? Well, that would be when y equals -13. And so the vector that you would write would be -11, -13. Remember, you use your braces, not parentheses. Okay? So that would be the vector you would use. And if you look, 3. I'm sorry, that should not be a negative 11. That should be a positive 11. I don't know why I put a negative there. If you add 11 to negative 3, you're going to get to an 8. And then if you say 12 minus 13, you're going to get to a negative 1. So that would be how you can check and make sure that you're on the right track. Okay, so now we're going to look at the practice problems. We have a line segment that has A at 11.5 and B at 4.9, and it's translated 5 units up, and it asks for the coordinates of A prime and B prime. So you'll pause the video and try this one, and then y'all can check your answers in a second. So if it's translated 5 units up, that is changing the Y value. The Y value got 5 added to it. So that means that A prime is going to be 11, 10, because you just add 5 to your Y value of 5. And then B prime is going to be 4, 14. The X values don't change, only the Y value. Okay, looking at the next practice problem. Again, pause the video and y'all try this one and then unpause the video to check your answer. So we have a triangle with vertices K, L, and M. We want to find the image of the triangle after the translation, and we want to show the pre-image and the image on the same coordinate grid. So on this one, I'm going to have to go by 2s so that it'll fit on my grid. I'm going to go over 2 and then up 2, 4, 5 for K. And I'm going to go over 1 and up 2, 4, 6, 8, 10, 11 for L. Then I'm going to go over 2, 4, 5 and up 2, 4, 6, 7 for M. And so that would be your pre-image. Now we want to find the image after we subtract 2. So that means that it moves to the left 2 and it still moves up by 1. So I'm going to do that in another color. So our K is going to get pushed to the left 2 and then down 1. And so it's going to be K prime here. Our L is going to go to the left 2 and then down 1. So it would be right there. And then our M to the left 2 and down 1. So it would be M prime right there. And then you connect your vertices to make your new image. And so that would be your pre-image and image on the same coordinate grid. So looking at this next one, y'all pause the video and then we'll unpause the video after you've tried it and I'll go over the correct answer. All right, so we want to find the coordinates after it's translated by the vector 3, 1. So basically, each of your X values is going to get 3 added to it, and the Y values are going to have 1 added to it. Now, it didn't say to graph the new image, but if you would like to, you can if that helps you. But basically, I'm going to find each of my points. My A is going to be at 1, 4. My B is going to be, I'm sorry, that's going to be a 2, 4. It's going by 2s. 2, 4. My B is going to be at 7, 4. My C is going to be at 10, 6. And then my D is going to be at 5, 6. And so then for A prime, you're going to end up with 5, 5. For B prime, you're going to end up with 10, 5. For C prime, you're going to end up with 8, 7. I'm sorry, that's D prime. I'll write that one in a second. For C prime, you're going to end up with 13, 7. And then for D prime, you have 10, 7. Not 10, 7. 8, 7. And so that would be the coordinates after the translation. Okay? Looking at the next one, the last practice problem. Y'all try it and then pause the video. And once everyone's finished, y'all can check your answer and unpause the video. So we have 2 points, 1, 3, and 4, 3. And it goes to 9, 4, and 12, 4. And it wants to know what the component form of the vector that gives that translation would be. So we want to go from 1, we want to add some x value and get to a 9. And we want to go from 3, add some y value to get to a 4. So our x would be 8 and our y would be 1. And so the component form would be 8, 1. And you can check 4 plus 8 is 12, 3 plus 1 is 4. And so that would be your answer. For the challenge question, we want to sketch the translation by the vector -2, 4. So on this one, I'm going to use the computer to help me do that. Y'all feel free to pause the video. But we are going to basically take our figure and we're going to go to the left 2 and then up 4. So to the left 2 and then up 4. And you do want to have an arrow on your lines that you draw. And then we're going to do the same thing. I'm just going to do it with each of the 5 vertices. I don't feel the need to do it to any other points other than those vertices. And so then your figure is going to end up there. So it should look something like that. But that would be the basic idea for that translation. So hopefully you get that idea. You do have to have those black lines with arrows drawn in. And you do need to have the arrows showing that it's going from this point to that point. Okay, so your homework is 1 through 30. So you'll need to make sure that you do those tonight so that we can go over any questions you have tomorrow.